So first off, I'm John Kelvie, and we're really excited for you all to join us for this webinar. Monitoring and testing is something that we're very excited about as a company, and I personally really love and am passionate about. And so we're eager to show you our best practices, as well as some of the great tools that we've built to assist in it. At the same time, this session, it's meant to be interactive. I'm not going to be able to see your questions if you write them there, but we've got a bunch of folks actually from Bespoken that are in the chat there. So if you type up questions, they'll feed them to me, and I'll try to answer them as we go along so that we can make this interactive and it's not just me talking at you for the whole time. So with that introduction, let me get started. So first of all, we've actually got a number of Bespoken people in the chat room, but in particular, obviously myself, I'm here. I'm the CEO and founder of Bespoken. Additionally, Bo Schrader, who is our head of marketing, you'll see her in the chat room, and Yvonne Perez, who leads our customer success. And just a quick introduction to us. I assume most of you guys are somewhat familiar with Bespoken, but just a little bit of background. We provide monitoring and testing tools for voice apps. We're a recognized vendor of Amazon and Google. We have over 700 apps currently being monitored, and we have over 1,000 developers using our software. And additionally, just as a bit of deeper background, we do have a long history with speech recognition and AI. Prior to this, I was the co-founder of Zap Media. We were doing interactive audio ads, which means ads with speech recognition on mobile. And we spent a lot of time making that scale, and we spent a lot of time making sure that it really works well, that the speech recognition is working great, that the AI parts are working great. Really learned a lot of lessons around how to test that sort of system at scale. And we've been bringing that knowledge to these new apps that are being built for Amazon and Google. And what would we like you to come away with from this presentation? We're covering a fair amount of material. You know, maybe it's too much. I'm not sure. You guys will tell me that. But at a minimum, we'd like you to have an awareness that these tools are out there, that you can do testing, automation, and monitoring for your voice apps. I'm not sure that was a true statement, you know, even 2 months ago. And we like to think that we're making that a lot easier, and it's becoming more true every week. And we're certainly trying to do our part to assist with that. So we want you to know that these tools are out there and it is possible to do these things. We want you to keep in mind the different layers of testing. That's represented by that little cake there that you see. We're going to go through those, but we see manual testing, automated unit testing, as well as automated end-to-end testing, all as essential components of building great voice apps. And then lastly, we want to show you and we want you to come away with a sense of the best practices for pulling it all together. And so that's that little cutout diagram there on the right. So the idea is we're going to show you these tools. We're going to show you some of the pieces or some of the ways that we've brought it all together. And we're hoping that you'll feel confident you can bring it together for yourself as well based on this presentation. So with that, I'm going to jump into the testing component. So first of all, manual testing. What does manual testing involve? Obviously, you can do manual testing of an Alexa skill using the devices themselves. You can do them using things like the echosim.io. You can do it with the Reverb app, which we like a lot. And those are all using your voice, and that's an essential part of testing. In addition, you can do manual testing using voice-free tools, such as our BST command line. We find that's very helpful as well. And each one of them can be useful depending on what the scenario is that you're working on. So we're going to go into that in just a little bit with a demo. But first, we also want to talk about unit testing. So this is another critical part for building great skills. And the automated unit testing, I think most everyone probably knows that's really important for regression testing. But I'm a developer, or my background is in development, and I'm still actually very active as a developer. And it's also really worth keeping in mind that unit testing is extremely helpful during the development phase, and it allows you to quickly identify bugs. So we'll go into a little bit about it. It helps with how it helps with that. It's also an important component for creating your code coverage, which gives you an assurance about the quality of your code and the thoroughness of your testing. And then, one thing I would highlight is that in general with unit testing, not always, there's different approaches, but you're typically trying to minimize your dependencies. It's the opposite of an end-to-end test. And so when we think about unit testing and what I'm going to show you here, we're really focused on testing the skill and the skill code. So if we think about the overall architecture for an interaction with a voice app and with Alexa, we're concentrating on this box, the skill behavior here with the unit testing part. But we don't only want to concentrate on that. We also want to talk about the end-to-end testing, and we want to make sure that we're doing that. Both are important because with your unit testing, your code is good. With your end-to-end testing, you're looking to make sure that the whole system is good. And in particular, you're really looking to make sure that your interaction model is working well. And so that means that you're looking at the speech recognition and the AI and really trying to ensure that those are functioning correctly. I think everyone who has spent time with skill development and any sort of voice app development, they know that you're going to run into issues with your intent model. And especially if you just build your skill and you don't do any testing on it, with actual devices or using your voice, quite frequently you can see that you might have to make significant changes to that interaction model. So the end-to-end testing is something you can set up front. You can use it for testing that interaction model as you're developing. And then once you have it there as a regression test. So then as you're evolving that interaction model, you're able to ensure that things are still working. And one other point I would just also, it's a little more subtle, but I just was seeing a conversation about it in the Alexa Slack channel, which is that anecdotally people are consistently or routinely observing that they see, it seems that in some way the speech recognition has changed or my interaction model has changed. Not something I did to it, but that just the behavior of the system itself, of Alexa, has perhaps changed. So, having this sort of end-to-end testing, it's insurance against those changes, because you can be running through actually testing against the Alexa voice service and then have that, that confidence that it's actually working. So that's an overview of what we have so far, or these pieces. Now I'm going to go in and demonstrate them. And actually, I should say before that, I'm going to just do a quick demo, a live demo using Alexa of the skill that we're going to be walking through here. So this is a skill, we call it Guess the Price. It was done by a developer who I think is actually on this call, Juan Parada. And Guess the Price is just a fun skill that's kind of similar to The Price is Right. So I'm going to do a quick demo for you guys of that so you have a sense of how it works, and then we'll jump into the different testing components. Alexa, open Guess the Price. Oh. It's a little...
Sorry, your Echo lost its connection.
Just going to try that one more time. Alexa, open guess the price.
Welcome to Guess the Price.
Okay, that's timing out for some reason. The interaction is, it opens the skill, it asks me how many players there are.
Sorry, your Echo lost its connection.
And then it asks me, it describes an item and asks me to guess how much it costs. So very simple skill. And I'll just show you here. We're actually going to do the initial command line testing. So I'm going to be using initially our emulator piece, and we call that virtual Alexa. That is actually the part that tests the skill in isolation, and that's what we use for our unit testing as well. And so we have that available in our command line, and what it's actually going to do is it's going to be generating the JSON payloads as if it was coming from Alexa. So if I say launch, it generates the request here that you see. And then we have this response where it's saying, welcome to Guess the Price, how many persons are playing today? And so we actually do state management, which is a new feature that we added recently, but it's pretty neat. So I can now respond to this as if I'm in session, and I say, how many people are playing today? And I'll say 1. And then it asks me what my name is, and I say John. And great, now we're into the game. It's asking me, how much does a DC Comics Pez dispenser cost? Great, so I'm going to guess that costs, let's say it costs $2. All right, and so it immediately then asks me for another item, but if I go up here, I can see the response. I said $2, the actual price was $20. So I was pretty far off there. That's too bad for me. But you can see here the request and response, and this is just a nice way to do manual testing. And again, this is using our emulator. So we're simulating the JSON, we're simulating what Alexa does internally and generating JSON as if we were Alexa. But we're not actually using Alexa. But we can. So that's our speak command. So I was just showing you utter. Speak, it looks very similar in terms of what we're going to be typing, but it has a difference in that it's going to take the text of what I type, it's going to turn it into audio, it's going to send it to Alexa. Alexa in turn is going to interpret that, and it's going to send it on to our skill. So what we saw here, I said open guess the price. And then it comes back with the transcript saying, welcome to Guess the Price. How many persons are playing today? And then I say 2, and it says, great, contestant 1, please tell us what is your name. And so this looks pretty similar to what we're doing with the utter command. But the difference is, again, that this is actually going through AVS. And so this 2 is getting turned into audio. And this reply here, this is coming back as audio, and then we're turning it into text. So that's really neat stuff. And these are great manual testing tools. I hope you see these as useful manual testing tools. But now that we've done some basic development on our skill, we want to shift and we want to start thinking about, okay, how do we use these same sort of core pieces so that we can have automated testing? So we're going to go ahead and take a look at the Guess the Price project here. And this is just actually open and available on GitHub, so you can take a look at it yourself. And so this is a unit test that uses the virtual Alexa component, the emulator that I described, to actually test our skill. And it's easy to work with. You're working with it in the same way, basically, that you are in the command line. You say things like utter, and then you get back the response payload is JSON, and you can write tests against that. And we don't have an opinion on how you construct those tests. I mean, we're using Mocha and Kai here. We use other testing tools. There's lots of great test frameworks, assertion frameworks. You can use whatever you want with this. The key thing is that it's easy to actually interact with your skill. So in this case, I'm saying utter. I get back a reply. I give it a name. In this case, I said there was 2 contestants, so I'm giving it 2 names. I give it the dollar amount, so I'm guessing how much something cost. And I run that test through. And so that was one sequence. But we actually have a number of sequences in here. And so we're really trying to make sure that we're testing all our scenarios. And just one thing I would highlight about this is, if you had an error at this step in the sequence, the game is opening up, you have to tell it the number of players, you have to give the names of the players, and then you're going to actually guess a price. Well, if the error happens only when there's 2 players, and only when you get to this step in the process, if you're testing that manually with voice, guess what? That's going to be extremely tedious, right? Because you're going to be repeating those steps over and over, and just hoping that the error occurs, hoping that you can catch it, and then identify what the root cause is. With this unit test, if you construct it this way, you can actually hook this into a debugger, step through, and isolate that error extremely quickly. And so it can take your development time down significantly. It can cut it. Bugs that might take you a few hours to fix, you can fix in 5 minutes, especially if you have all your nice unit tests already constructed. Now, before I go further, I see there's a question. How do you test a skill with dynamic responses? For example, a welcome response, but has 4 different variations. So if there's 4 different variations, depending on what they are, if they all have some common piece, like they all say welcome, but then the part after welcome is different, you might just do an include. So sort of a simple match, if that makes sense. You don't have to match the whole thing, and have a looser test, assuming that you're ensuring then that it is actually hitting the right intent, which a lot of times is what you're checking. If you want to make sure that it is actually exactly returning those 4 different values, off the top of my head, I don't know the assertion, but I'm sure with, this is using Kai, I could construct, just put together an array of the possible responses and say, oh, if it's any one of those responses, match that one, or it's okay. I'm pretty sure that's an assertion that's part of Kai. Worst case, you'd have to write a tiny bit of code yourself. And I see another question here. Does this test cast talk to your Node.js function in your system, or does it ping Alexa and get the response from AVS? So this is, again, this is using our emulator, and this is just running it locally. And actually, when we're instantiating this, we're telling it, okay, where's the JavaScript file? And then where's our interaction model? So the intent schema and the sample utterances. So this is all working just totally locally. This is not going through AVS. With this unit test, we're really seeking to minimize the dependencies. So it's all happening locally, and you really don't need any infrastructure in place to run it, which is a great thing. And it's, thank you for that question, because it actually highlights what's an important thing with the distinction we're trying to draw between unit tests, automated unit tests, and automated end-to-end tests. And so then another question, what's the actual benefit of testing using the speak command, transforming text to from my audio, and what are you additionally verifying compared to using the other command? Yeah, so that's a great question, and I hope I'm explaining that well, because that's a really important distinction that we want you guys to understand, is that when you're testing with AVS and you're actually generating audio and you're sending against it, you're actually ensuring that your interaction model is working correctly. So this unit test, I mean, this is going to make sure that your code is functioning properly. When I show you the end-to-end test in a moment, what that's really making sure of is that your whole skill and your interaction model in particular is working right. And so to the point of, oh, this is really ensuring your code is functioning correctly, we can go over here and we can see our code coverage. And so this is codecov.io, which is a tool we like for code coverage. There's a bunch of them out there, but this is a nice one. And we can see that we've really tested the heck out of the skill, which is nice. And in particular, like a lot of skills, a lot of our behavior is in an index.js file. And so we're using the Node.js SDK here for Alexa. And it's a pretty typical structure we have here, where it's, it's the state machine that I think most Alexa devs are familiar with. And all these lines that are green, this means that we've actually got unit test code that's ensuring that it's working properly. So it's not perfect code coverage. Perfect code coverage is not always the ideal goal, but we've got excellent code coverage here. And with that, we can feel confident that it's working correctly as we're developing it. We can quickly debug it, as I was mentioning. And then we have a great regression test as we go forward. And so with that, let's take a look at our regression test, or our end-to-end test. So this looks pretty similar, right? But this is actually using our virtual device piece, which is going against AVS. And so there's additional infrastructure that needs to be in place, like using that unit test that I was showing you. You don't have to put anything into the Alexa developer console. But for this, you actually have to have set up your interaction model in the developer console, have set up your skill there. It needs to actually be available via Alexa for testing. But assuming that you have that, you then can write a test, very similar semantics. In both cases, you're dealing with these utterances. But again, this is actually going to run against Alexa, and it's going to be testing the skill. It's going to be testing your infrastructure. So it could pick up on issues you might have with Dynamo or S3. But most importantly, it's going to be working with that interaction model. And one conversation that I do have regularly is people say, well, are you using real voices or using speech, text to speech? We are actually using text to speech. It's maybe even better using real voices, or both are very good. To use real voices, to use text-to-speech are both good. But just using text-to-speech, you have a chance to really exercise that interaction model and get an additional layer of testing, which we think is great. And so this is our end-to-end test. Very easy to construct, similar semantics, like I said. One thing I would mention here, and even to the question that was earlier around, oh, what if you had a bunch of responses? Having, in general, you're looking to make sure that the intent is being handled properly. That the right intent is being passed to your code, and that then the correct response for that intent is coming back. So you don't need to do really tight tests, against the exact response, or at least I wouldn't say that's my best practice. That's even more true when you're testing against using AVS. We are using speech to text on the other side, and it's imperfect. It's probably got a 90, 95% accuracy rate. So you may not always get a perfect translation of what was said. So in that case, you want to test some component of what's coming back, enough to make sure that the right intent was fired, it was in the right state, and then it did handle it correctly. And so even though it's not perfect, I should also mention that it's predictable. So it tends to make errors in the same way. So you can run it through and kind of finesse your test to get it into a nice state. I see question 4. Please explain virtual device more. Yeah, so gee, I should probably have a diagram for this ready to go, but I'll just try to talk through it. I mean, the idea is it's going to take this text, it turns it into audio using a text-to-speech component. It sends it to Alexa, as if you're talking to it, I should say up front. I mean, really, so a virtual device, it's as if you have an Echo or some Alexa device right there in front of you, but then you're just able to message it instead of actually speaking to it. So it's kind of a neat thing, but it really does work just like an actual device. And if you play around with this a bit, you'll see that, constructing tests for it is a little bit trickier also because it has the same session behavior as your Echo, so it can time out. So for example, if you guys walk away from this webinar and you go and you start immediately using the speak command, which I would encourage you to do. But if you try to run through a bunch of commands at once, you have to type them fairly quickly because it's got a session that stays open for a certain period of time. So it really is just like a real device. It's just that we've enabled it so that you can engage with it without having to use your voice. I hope that explains it well. But so you see here that we have these end-to-end tests, we have the automated unit tests. How do we put this together into a continuous integration piece? And in general, automate this. So I should mention here, we're using Circle CI. That's sort of our preferred continuous integration tool. But there's lots of other great ones, and any one of them will do fine for this. And if you're not familiar with continuous integration or continuous deployment, or if you haven't used it much, just a quick overview on it is that, it's going to automatically execute your tests and even deploy your code whenever people make commits to your source code repository, such as GitHub. So, every time developers make changes, you want to make sure that all the tests are passing. In a perfect world, every developer would always run all the tests on their own local environment before they ever checked anything in. But we know that doesn't always happen. And we also know that people's environments are imperfect. I think it's one of the great jokes about computer programming with people saying, but it worked on my machine. So your continuous integration environment is a clean, pristine environment that's going to take that latest version of the code in the repository, run any automated tests against it, and in the case here, not going to spend as much time on it, even do automated deployments. And so I showed you our automated tests. That's in that index.test.js. And we're going to run those every time there's a check-in. And actually, one thing I should say about Circle, it would run this actually automatically. I put this in here just for clarity's sake. But what it's going to do every time there's code committed, it's going to run npm test. And our npm test is going to run that index.test.js. And the net result of that running so one, we should get that nice little badge, but if we want to see more details, so anytime we're making a change, this is what we want to see. Success in green. And, you know, really with almost all the tools that are out there, I mean, that's what you're looking for. And that's what you're going to end up with is you're getting green or red, whether you're using Travis or Jenkins or Circle. And if you get something that's red, you're about to get a bunch of emails. And maybe your team's about to get a bunch of emails. So you may feel shamed if you make a mistake or you mess up the continuous integration. So this is just running every time we commit it. And in addition, that code coverage that I showed you, that's also going to get updated every time. So before I go further, I see there's a question, and that's how do you handle audio files on the regression? For example, when the user requests an interview and skill pulls an audio, how do you validate that with just the audio file name? So I have another example for an audio player skill that does just that. If I'm answering the question correctly, like, so the skill that I built, it's for a podcast and it's based on an RSS feed. Now, the actual podcast RSS feed is changing all the time. So what I went ahead and did is I have a version that's static of that RSS feed of the XML that always gives back the same audio file. So it's always the same RSS feed with the same files in the same order. And I can write unit tests against that. And, swapping out one RSS feed versus the live one that's actually changing, that's just a configuration parameter. So that's how I handle that. I hope that makes sense and answers your question. And I see, okay, the question, I don't think I got the whole question here. It says, how do you integrate coverage details to Bespoken? I use Bespoken tools for my Alexa unit testing, but do not, I don't see the rest of that question. I'm gonna hop over here to see if I can see it. Okay, for whatever reason, I don't see the rest of that question. I'll be on the lookout for that, and I'll try to answer the rest of it. Oh, you do not get test coverage. Okay, so again, I mean, we're showing you our tools, but we're also showing you best of breed pieces. So how did I integrate code coverage in here? So if you've got this hooked up, if you're using Mocha, for example, getting this to actually produce code coverage, it's really easy. There's a great project called Istanbul, which then has a command line tool called NYC. I don't know why its project is Istanbul and the command line is NYC, but basically, if you you install it here as NYC, and then for your test runner, your stock test runner might be just Mocha, whatever the names of your tests are. You just put this NYC in front of it, and it's really going to take care of the rest. Really very easy to work with. And so this is going to generate code coverage information, and then the actual report is in this post test where it says NYC report, and then you say code cov. So sorry, I made that. I should have highlighted this post test step to clarify. This is very important. That this is NYC then generates the proper code cov artifacts, and then you generate a report and hand it to code cov here. I think I've cut and pasted these lines, into, I can't even tell you how many projects. This is pretty standard stuff. This is to work with code cov here. There's other popular tools, but if you're using code cov, this is all you have to do. That's another NPM install, but really pretty straightforward to get set up. So using us with the with unit tests, this is basically what you want to add. Be happy to follow up with you after this to clarify any of that. But that's great if you already have your unit test set up, and I think you'll be even more delighted if you include these pieces and you get that code coverage in there. And then you can add a pretty badge too, which, who doesn't love badges? The next piece I was going to show here and I'm not going to go into a huge amount of detail on this, is just the continuous deployment. We don't have enough time in this webinar to do a deep dive on continuous deployment, but it's not that hard. And I want to give you a sense about how we approach it. When things are pulled into master, we do a pull requests. Those pull requests get reviewed. When they get pulled into master, the idea is that then it's going to be ready for sort of official testing. If you have a QA team, that's the time when they should get involved. So we have a dev environment, and this is a Lambda, and we're going to automatically deploy it out to that dev environment. Inside that shell script, we're doing some file manipulation, and we're doing some neat stuff with the Ask CLI, and it goes out to dev. And once it goes out there, this is how we integrate our end-to-end tests into the process. Then we're going to run our integration. So we're also going to make sure that deployment happened correctly and that there wasn't problems with it. So if we get an error on that, that means, there was a problem with those updates. We better take a look at that new interaction model that went out. Really advanced stuff, we'd automatically back out that change, put in the old interaction model. We haven't gotten to that yet. When we do, we'll let you know. But just having that sort of automated deployment for testing is great. And we did some of the same stuff for prod. With prod, we do force a manual step. You do have to sort of say, hey, this is ready to go to prod. So that's a little bit on continuous deployment. How are we doing on the questions here? I don't see more, so I'll assume that we're good. So I'm going to go back to presentation mode here. I didn't show you this slide, but just to sort of reiterate, this does sort of emphasize how this works. The emulator is just interacting with the skill. The virtual device is going to our virtual device service, Alexa, and then to your skill. This is a good reference to kind of see how it's working. So we talked about continuous integration. We talked a little bit about continuous deployment. Monitoring. So there's two types of monitoring that we think you should be doing. And one is proactive, where you're actually paying the service in some fashion. We're going to show you a little bit about how we do that. And basically on some regular interval, making sure that it's functioning correctly. We think that's a really important point. And we encourage people to use our virtual device piece for that sort of testing, because it is, again, it's end-to-end testing. Knowing that your code is working correctly on a regular basis, to check that every 30 minutes, is that really that helpful if, say, Alexa isn't working right? You want to know that Alexa is down, or you want to know that Dynamo's down. I can't say that we're going to be able to tell you exactly where the problem lies, but if you hook in those end-to-end pieces that we're showing you, you're going to know when there's something wrong for sure. And from there, you can jump in and start to triage it. Additionally, just tracking what's happening in the normal activity, as opposed to just the sort of pinging that I'm talking about. Also to be looking at the errors and exceptions that are happening for your users' interactions, whether they be code, infrastructure, or Alexa. That's also an important part. We have some nice logging for that, and we're adding even deeper monitoring for it. And so one piece that we've actually launched recently is this validation. And what I'm going to show you here, this is the same thing that I showed you on the command line, and it's the same thing that I showed you with that end-to-end test. But this is another way that you can access this virtual device. And so this is a simple sort of scripting format that we have, where the left-hand side is what you're saying to Alexa, and then the right-hand side is basically a loose match test. It's a contains. And you can click run on this. And it's not real fast. I mean, one thing about using the virtual devices is they're not fast. It sort of works about the same amount of time as it takes you to talk to a device. But it's actually going to run through this script. And so this is a neat way to play around with the technology that we offer, which we think is really helpful. Additionally, one of the things that we're very excited about is we are working on tying this into our monitoring, so that this will be executed on a regular interval and then give you reports if there's any errors. So that's a piece that we're actively working on now. It's not available yet. I do want to be clear about that. But it is something that we're putting together, and we'll be excited to tell everybody about once it is ready. So I see that there's a question: is there a simple version of testing like GitHub, Alexa Cookbook test flow? So that, I would say, is akin to this. Now, the test flow is using an emulator. This is an example that's using AVS, so it's a little apples and oranges. We don't have something that just does a simple little script format like this for the virtual Alexa emulator piece. I will say I've seen some people that have put together their own versions of that, which I think is pretty neat. That's not something that we do at the moment, anyway. And so I've run through a lot there. it's 10 of. So this is time that we reserve for questions. So please just ask me any questions you have. Also, I should mention that we have a polling section there. I think there's 4 questions in it. If you folks that are online would answer those questions, that's really helpful for us. So I see there's a question. Can you go from validation and dashboard to generated end-to-end code for CI? So that's a really interesting question. I mean, the quick answer is no, but I mean, it immediately gets my mind spinning like, gee, that seems like a neat idea. How hard would it be to do? Yeah, so that's something to contemplate. Okay, so one thing I should highlight, that format that you see there in the validation piece, that is actually exposed. Like you can take that script and we have a class, like you can basically take that script and plug it into a test very quickly. Basically it'd be 2 or 3 lines of code. So you can do it, I would say, quite easily. You know, but it's not going to be, it's not push button. But I could show you an example of that you might find helpful. But doing that as a push button, that could be valuable for people as well, because obviously, you know, that could be a very useful feature. And then you don't have to do any programming, which is nice, right? More questions? Well, I mean, we're just waiting here, so I guess there aren't more questions at this point, but we'll keep the session open until 2. So if you do have more questions, just ask us. I just pulled up this screen with some resources, but I see there is another question. What about testing for cards and templates for Echo Show? So one, using the emulator, you're just going to get back that response JSON and you can test that. And so that's very straightforward. On the virtual device side, we actually do get back the card, and that's part of the payload. I didn't show that in my example, but you can actually test the card. So that does come back from AVS, the card information, and you can write tests against the information there, against the text, as well as against the images that are displayed. So that's a nifty feature. We don't have the ability yet to test the render templates with the show. I'm hopeful that will be soon. That's actually a limitation for us, as in, you know, we're not in you know, I think there's basically, that's not widely available yet, the Echo Show AVS client capability. And it's not available to us yet. As soon as it is, we'll make that, you know, we'll make that available in the tool, and then you'll be able to do those tests on the display template as well. The resources I put on here, a link to our dashboard, the virtual Alexa, the virtual device SDK, guess the price, which is the skill I was going through. There's a lot of really neat stuff in there. I think even more than I had a chance to show all of it. And where we plan on going from where that is today next is actually turning that into a full-blown template that you can use for your own skill development. We think that would be helpful. And then just other small reference items. Here's the npm command. for the Bespoken tools, for installing that. And then here's a couple interesting blog posts. You can take a look at those at your leisure. Like I said, we'll keep this open till 2 if anybody has more questions. But just in case people do start to drop off, thank you very much for attending. This was fun doing this, and I appreciate all the people joining and the interest in what we're doing. Do you support testing, monitoring Alexa routines? So I just got to admit, I haven't tried testing them yet with this. It should be feasible, though. Yeah, I need to give that a try with this. That's just another AVS function, so should certainly be doable. But I would need to give that a run through. Or you could give it a run through. Let us know how it works. Okay, so yeah, I'm looking at the chat window now. I appreciate all these comments, especially the feedback on it. This is really helpful stuff. I'll review this in more detail. And Jonathan, thank you for highlighting Dabble Labs video. So we haven't done a lot of videos, but Steve Tingaris there put together just great video on how to get our stuff set up and work with it. It's great stuff, and we appreciate what Steve put together there, and it's a neat resource. And I see you also mentioned all the other tools we have. Yeah, there's a lot to cover. I tried to cover a good amount here, but I know that there's more. I'm looking for Steve's course here. I'm going to type in. Thanks for including that. You found it faster than I did there, Jonathan. Yep, that's it. All right, well, it's just about 2 o'clock, so I guess we'll wrap up here, but this has been great. I really appreciate everyone's participation. And I'm laughing at your question there, Jonathan. I don't know the answer to why Steve pronounces console as console, but I have a lot of funny pronunciations too, so I sympathize. But really appreciate you guys joining. I hope this was helpful. We'll probably be looking to do more of these webinars in the future. So certainly your feedback on what's useful, what's not, what you'd like to hear us talk about, we'd love to hear it. So thank you very much, and look forward look for the presentation as well as this webinar that it'll be available to you to look at later. So thanks, everyone.